We're in the last section of Chapter 9, which we're going to model relationships. First, we're going to sketch a graph of real-world situations. Then we're going to compare properties of functions. Then we're going to choose a model for real-world situations. We're working at 3 different types of functions today, and we've been working with these the entire year. We had linear functions, which follows this equation, which has a straight line. Exponential functions, which could grow exponentially or decay exponentially. And then quadratic functions, which form a parabola facing up like this or facing down like this. First, let's sketch a graph of a real-world situation. It says the water from one water cannon on a firefighting boat reaches a maximum height of 25 feet and travels a horizontal distance of about 140 feet. Describe the type of function you would use to represent the water's path, and sketch it. What do the intercepts represent? First, we need to figure out the scale of y and x on this graph. Well, the maximum height is 25, so I can have 25 right here. And the maximum distance is about 140, so if this was 150, this would all fit into this graph. The water comes out and its height is increasing at first, but as it continues, gravity is going to start taking effect and it's going to start pulling it back down to the water. So that to me would be a quadratic function. And this is a little bit up to interpretation from me. But I do know that the water is not being shot out of the water level. It's actually being shot out of the air a little bit, maybe 10 feet out of the air. So we could start it around what I would say is 10. Then I can draw my parabola. It needs to hit the water around 140. And it needs to reach a maximum height of 25. So if we write our parabola, it goes up, reaches the maximum height, and then it comes back down and lands at 140. And this would pretty fairly represent the path of the water as it travels at a horizontal distance. It reaches a height of 25 and it goes 140 feet. Now we need to say what the intercepts represent. Let's first focus on the x-intercepts when y is 0. Normally in a parabola you have 2 x-intercepts, and I suppose if this kept going it would cross the x-axis, making another x-intercept. But this did not happen. The water is being shot in this direction, so we only have one x-intercept. And what's happening when we travels 140 feet? That's when the water reaches 0 feet above sea level. So the x-intercept, you could say the water lands. Now we could focus on that y-intercept over here, when x equals 0. What does that represent? Well, y is representing height, right? So it would be the height of the water when it's first shot out of the boat. So water when first shot. Now we can compare properties of functions. It tells us to decide which linear function is increasing at a greater rate. It says function 1 has an x-intercept of 4 and a y-intercept of -2. And then function 2 includes the points in this table below. Since it's a linear function, we can find the slope. Remember, the slope is the rise over the run. So if it gives us the x-intercept and the y-intercept, that would be 4 and 0 for the x-intercept. The y-intercept would be 0 and -2. So our rise would be -2. Our run would be -4. -2 divided by -4 is 0.5 for a slope for function 1. Function 2 now. Tables are a little bit easier in my opinion, especially when I see that there's a run of 1. What's the rise? The rise is 5. So a slope of 5 over 1, or 5, is much bigger than 0.5. So we're going to say function 2 has the greater slope. Now we need to decide which quadratic function has a lesser minimum value, meaning the lowest point of a parabola. Gives us function 1, which is the equation 3x squared minus 12x plus 1, and then function 2, which has a graph given below here. Well, the graph you can probably tell pretty quickly. It's -2, -4, -6, -8. We'll say -9 for the graph here. Now we can use that vertex formula with this equation to find that minimum value. The formula is -b over 2a, meaning we'd have -12, so +12 over 2 times 3. 12 divided by 6 is 2. Let me remind you, we found the x value. We did not find the y value yet. So some of you might be tempted to say, oh, -9 is lower than 2, but let's hold off our judgment 1 second here. We can plug this 2 in for x, and then we can solve for our y value. So 2 squared is 4. 3 times 4 is 12. Minus 2 times 12 is 24. Plus 1. 12 minus 24 is -12. Plus 1 is -11. So it's a good thing we waited to C, because the y value when x is 2 is actually negative 11, which is lower than the negative 9. So we're going to say function 1 with the equation has a lower minimum value. Now we can look at a real-world situation and choose a model for it. It says a table shows a distance that Juan covered per hour in the first 4 hours of a triathlon. Based on the change per unit interval, choose an appropriate function to model the situation. What this means is it changing at a linear rate, an exponential rate, or a quadratic rate. Well, the hours are going up by 1, which makes it easier to calculate for us. So the change in miles run between the first and second is a drop of 0.6. And I see that the second one isn't a drop of 0.6, so that means this is not linear because it's not changing at a constant rate. Let's check to see if the change of the change is constant. Let's see if that's quadratic then. 5.4 down to 4.86 is a change of 0.54 on drop. The next change between 4.86 and 4.374 is a drop of 0.486. So if it's quadratic, these are all going to be changing at the same rate. So this is a change of 0.6. This is not a change of 0.6, meaning that this is not quadratic either, which leaves us with exponential. It must be exponential. Let's see if the rate of change is the same. 5.4 divided by 6 is 0.90. 4.86 divided by 5.4 is 0.90. And then 4.374 divided by 4.86 is also 0.9. So this is actually an exponential decay function because b is going to be less than 1. If we write our equation now, it would be y equals a times b, which is 0.9 to the x. And we could solve for a, but it's not really asking us to do that, so we don't need to do that for this one.